All right, example 5, find x and y. Now, notice this problem. Same issue as before. We have an angle. We know we're trying to find other angles. This time we have 2 missing angles. We do have one extra piece of information given to us here, which these 2 sides are marked as equal to each other. If you see those little dashes on sides, that implies congruent sides, which means equal measure. And there's a property of an isosceles triangle, which is the base angles of an isosceles triangle are equal. Okay. Again, I'm basing this on a property not just because I feel like it or not because it looks like it. Those 2 sides are equal, making an isosceles triangle. That means that the 2 angles opposite those equal sides are equal to each other. So this angle down here, 50 degrees, this angle here, x, have to have the same measure, which means therefore that for this problem, x is equal to 50 degrees. Okay? Now, I couldn't really show any math there. Again, as Parker said, I did that in my head. But again, I'm basing it on a property. All right? Now, once I know x equals 50 degrees, how many degrees have we used up so far?
100.
100 degrees. So if I want to find out what y equals, going back to our 180 degrees in the triangle, subtract the number of degrees we've used in the other 2 angles, that gets me y is equal to 80 degrees. Right? If you have an isosceles triangle, you're going to have 2 measures you won't be able to find, or that you'll have to find. If you have if you have a scalene triangle, they'll usually ask you only for 1 because you have to know the other 2 angles. Once you know 2 angles, the third is always subtract from 180 to find the third.